Hey guys, today's video it's about still the AP calculus review, and first problem is it said if x plus 3 y to the 1/3 equal y, what is dy over dx at the point 2 and 8? So first thing we're gonna do, we're gonna differentiate the y equation dy dx. So we're gonna say d over dx x plus 3 y 1/3 equal dy over dx. So we're gonna simplify this distribution. So it will be dx over dx plus d 3y to the 1/3 over dx equal so dx over x plus d 3y to the 1/3 like that over dx equal dy over dx. Okay, and let's simplify this. So dy over dx, that's 1, plus what is the derivative of this? So that's y. So we can use the chain rule here. So we can say d over dx is equal to d over dy times dy over dx. It's the same. If these two cancel out, it will be d over dx the same. So we chain rule. All right. This is all just a step to simplify our the derivative here. So okay. So dy d over dx. So we can substitute d over dx, which is going to be equal to d. So let me get this here. So that's the dy over dx. That's what we're going to substitute for this. All right. So it's going to be d over dy d over dy 3y to the 1/3 time dy over dx equal to dy over dx. All right. So far, so good. Okay, so, and it will be equal 1 plus. So let's differentiate this in terms of y. So it will be 1/3 times 3y times 3. Or we can say 3 time 1/3 time y to 1/3 minus 1, right? Time dy over dx equal dy over dx. All right. So this will be 1 plus. So 3 times this will cancel out. So it will be y 1/3 minus 1, which is 1/3 minus 3 over 3, which is equal to negative 2 over 3. So it will be y to negative 2 over 3 dy dx equal to dy over dx. Okay. Then let's get all the dy on one side. Dy dx. So you can say y negative 2 over 3 dy over dx minus dy over dx equal minus 1. So we're going to subtract 1 from both sides, and we're going to subtract dy dx from both sides. And that's going to be the equation. Okay, then let's take the dy over dx as a common factor. So that will end up y negative 2 over 3 minus 1 equal to negative 1. Okay, and then the same as dy over dx time 1 over y 2 over 3 minus 1 equal to negative 1. Okay, then, so let's get a common factor here. So dy over dx, let's take y 2 over 3 as a common factor. So it will be y 2 over 3. No, this is going to be 1 minus y 2 over 3 equal to negative 1. Okay? So we can multiply both sides by y 2 over 3 by over 1 minus 2y 2 over 3. All right? Both sides. Okay, so this way we're trying to get the dy dx by itself in one side. So when we multiply dy over dx, 1 minus y2 over 3 over y2 over 3 times y2 over 3 over 1 minus y2 over 3 equal to minus 1 y2 over 3 over 1 minus y2 over 3. Okay, so this basically they will cancel out. Okay, now we have left over here was dy over dx equal to negative y2 over 3 over 1 minus y2 over 3. Okay, and then he said, what is the dy over dx at the point 2 and 8? So that is what he's asking us to do in the problem here. So the y value here, this is x, this is y, is 8. So we're just going to substitute for the y value, equal. So minus y is 8, 2 over 3 over 1 minus 8, 2 over 3. Okay, 8 it's the same as 2 to the third, which is 2 times 2 times 2, which is 8. Okay, so we can substitute for the 8 by this. So it will be minus 2 to the third times 2 over 3 over 1 minus 2 to the third times 2 over 3. Okay, so 3 will cancel out, and it's gonna left us with dy over dx is equal to negative 2 squared over 1 minus 2 squared. So negative 2 squared, that's negative 4. Over 1 minus 4, so it would be equal negative 4 over negative 3. So it will be 4 over 3. And that is the value, the dy over dx at the point 2 and 8. All right? Great. Let's take another problem. Okay. So more problem with this one and derivative. So what is the derivative? D over dx of x to the fifth minus 5 to the x. Okay, what's the rules? What is the derivative of the 5 to the x? So we have the rule d over dx 5 to the x equal to 5 to the x times natural log of the base, which is 5. So that's it. Let's apply this. So derivative of x to the 5 fifths, so it will be 5x to the fourth minus 5 to the x natural log 5. And that's the answer. All right. Let's take more problem. Okay. It said this one is the limit. So this, what's the limit when x approaches infinity? Or 10 minus 6x squared over 5 plus 3 e to the x. So he wants to know the limit of this. So what is the leading term here? The leading term here is e to the x. So we have to know the leading term. And also we have to know that e to the minus infinity is equal to 0. So that's two basic rules you have to know before you start solving this problem. So first step we're going to do, we're going to divide the numerator and the denominator by e to the x. Okay, so it's going to be the natural log, the limit of x when x approaches infinity, 10 over e to the x minus 6x squared over e to the x over 5 over e to the x plus 3 e to the x over e to the x. Okay. So that will limit when x approaches infinity. So it will be 10 e to the minus x minus 6 x squared e to the minus x over 5 e to the minus x plus 3. Because we have this 2, they will cancel out. Okay, so we have the rules here. It said e to the negative infinity is equal to 0. Then let's substitute for x equal to infinity. So limit when x approaches infinity. So 10 e to the negative infinity minus 6x squared e to the negative infinity over 5e to the negative infinity plus 3. So we know all this is 0, this is 0, this is 0, and we'll end up with 0 over 3, which is 0. So what is the limit when x approaches infinity? Is 0. And that's the answer for this one.